Oh, y'all, so 9.7 deals with applications using growth and decay. All right, so we're looking at exponential growth and exponential decay. So the thing is, we looked at compound interest formulas earlier in the section, and we seen when stuff was compounded monthly, daily, weekly, quarterly, and so far. So today the formula deals with the same stuff, but we're looking at what we call continuous compounding. Whoops. So we're looking at continuous compounding. All right, y'all. So here comes our formula. And the formula is really similar to the compound interest. So here we go. And they use this formula a lot for population growth. When you get into chemistry, if you learn about radioactive decay and stuff, they use these formulas. And then when you're making investments, if the investment is continuous compounding, it uses these formulas, okay? So y'all, here we go. So P of T equals P subscript O E to the K times T. So for this formula, they use a P because the formula is used a lot in population. So P is the population or amount in the bank at any time T. So we'll just call it our population at any time T. Okay, and remember, T is always in years. So if I know how many years went by, I can find the population or the amount of money in my account, okay? Now, P subscript O. So this is just a subscript. Basically, it's an O that stands for like the original. So we're looking at our original population, our original investment. So this would be our initial population. All right, remember E is Euler's number, and that's equals like what, 2.817, blah, blah, blah. But this E is replacing the stuff that was in the parentheses, the 1 plus the interest rate divided by N and all that fun stuff. So we use E when it's continuous. Now, K here is the interest rate if you're doing a problem involving investments. When you're doing formulas involving population, K is what we call the growth rate or the decay rate. So it can be the growth rate, decay rate, or our interest rate. Okay, depending on what you're using the formula for, it's going to stand for one of those three. And T is the same thing as T was in the last formula. T is our time in years. Okay, so that's going to be our general formula. Notice, and really the only difference is the E is replacing all that stuff that we had in the parentheses before. Now, we're going to look at two other formulas based on this one. The first one is what we call our double time formula. And the double time formula, double time is when our initial balance doubles in size, or when does our initial population double in size. So this double time formula will give us the amount of time that it takes for it to double. Now, instead of a little t like time has, double time has a capital T. And y'all, the double time equals ln of 2 divided by RK. And remember, K is the growth rate. So T means double time. And then K is still our growth rate, or our interest rate, okay? So if you're investing money, you can use this formula. If you got continuous compounding, you can use this formula to see how long it'll take for your investment to double. Okay? Now, we can also find the growth rate formula. If I know the double time, I can find K. So y'all, K will equal the ln of 2 divided by our double time. Okay, so the growth rate equals ln of 2 over our double time. Okay, so if you want to solve for T, you're dividing by K. If you want to solve by K, you're dividing by T on these, okay? So these are going to be the formulas that we're going to focus on today, okay? So this first one is dealing with population. So in the year 2012, the population of a city was 5.86 million. All right, so 5.86 million. Then it says the exponential growth rate was 2.12% per year. All right, so I got my initial population. I got my growth rate. So for part A on this one, they want me to find the exponential growth function. So basically, we're finding the formula. Now, they will have the PT. We just got to find all this on the right side, okay? So y'all, what we're going to do, we're going to take this formula and plug in what we know, because this formula is for the exponential growth of it, okay? So we got our PT. That's going to equal our PO, which is our initial population or our original population. And our original population was 5.86 million. So we're just going to put in our 5.86. We will assume that any answer we get will be in the millions, okay? All right, y'all, next we got our E. So bring down the E, Euler's number. Now we need K. Well, y'all are telling me the percent was 2.12%. So y'all, I guess what I need out of y'all, turn 2.12% into decimal form. Because remember, when we use these formulas, we need everything written in decimal form and not percent. So yeah, just convert that over. So what are y'all putting up there? 0.0212, good job. So it looks like Jackson moved that left twice and added me a 0. Good job. So y'all, that'll be 0.0212. And then we got our T. So this is the exponential growth function for this data. Now what you'll put in MATLAB will just be the right side, okay? MATLAB will have the PT of equals. You just put in everything else. But now I can use this formula, plug in for T, and I can find the population at any of these times T's now, okay? So for part B, they said the population of the city in 2018 is what? So we're going to use this formula and figure out what the population of that city will be in 2018. But y'all, if I'm going to use this formula, there's one thing I need to know, and that's the time. So if the formula comes from 2012, and I'm looking for the population in 2018, what's our time going to be? So our time will be what? The 2018 minus the 2012. All right, y'all, because we're just subtracting the years they're giving us. So that looks like 6 years. So basically, we're going to see how much this city grew after 6 years and what that population is now. So since we know that time is 6, we're finding P of 6. That'll equal to 5.86 E to the 0.0212 times R6. All right, y'all. So all we got to do now is go punch that in on our calculator. So I'm going to go to my calculator. And we had 5.86. Now, since my E has an exponent, I'm going to use the second ln to get that E with the exponent there and punch in 0.0212 times my 6 years. All right, y'all, so that looks just like our formula. So I'm going to hit enter. And they are rounding this off 1 decimal place. So that's going to be 6 points. So I'm looking at the next 6. Y'all, that 6 has a 5 after it. So we need to round that 6 up and make that a 6.7. So that would be 6.7. Now, MATLAB will have the million here. So all you're doing is punching in the 6.7 on that, okay? All right, y'all. So another use of that formula. Um, so notice on that one, they gave me how many years and wanted me to find the population. Well, look at this one. This one says the population of the city will be 8 million in about blank years after 2012. So notice the difference. Here, they gave me the number of years. I found the population. Here, they're telling me the ending population, and I'm looking for the amount of years on this one. So this 8 million will be our P of T. It's going to be the ending amount because we're still starting with the 5.86, okay? So we're going to solve this for the T this time. So y'all plugging in, I would have my 8 million equals 5.86 e to the point 0212 times t. We're now going to solve this formula for the t. So I'm going to get us started, but then I'm going to have y'all sort of help me a little bit on this. So I would tell you the first thing I want is this e stuff by itself over here. So I'm going to move the 5.86. Since that's being multiplied by the e, we're going to divide both sides by the 5.86. So I got 8 divided by 5.86 equals 5.86 e to the point 0212 t divided by 5.86. Now, I'm not going to divide this side yet. I'm going to wait till my last step to figure this stuff out. But all I wanted to do was to cancel that stuff out there. So I end up with my 8 over 5.86. That's going to equal e to the point 0212 t. Now, we got e by itself with a t over here. So we're solving for the t. But y'all, I can't solve for t while it's up here as an exponent. So I need to know if I want to bring that t stuff down so where I can solve that, what's my next move on this? And all this would come from those 9.6 equations we just did. What move brought those exponents down? Uh-oh, got y'all on a Monday morning, but here we go. Guess what? If I want to bring my exponents down, the only way to do that is to take a log or an ln on both sides. Well, since I got an e here, I'm going to take the ln of both sides. I'm going to do the ln of 8 divided by 5.86 will equal the ln of e to the point 0212 t. Okay, man, I didn't realize, yeah, you were typing all that, so it takes a while to type all that in. But good job. We're taking the ln of both sides. So now I'm not going to figure this out yet, like I said, till my last step. So I'm going to bring down the ln 8 divided by 5.86. But y'all, if you take an ln of e to the point 0212t, what can we write here now? So what does all of this now give me? Okay, good job. It gives me the exponent. Remember, the ln of e part sort of cancels out. So I'm left with the point 0212t. All right, y'all, good job. So my last step is to turn a 0.0212t into 1t by dividing both sides by the 0.0212. Because see, those are going to cancel, leaving us with our t. Now this, I will now punch in the calculator and see what that gives me. And y'all, this one, I think they are rounding 1 decimal point again, okay? So let's go punch that in. So we had the ln of a divided by 5.86, close parentheses, and then divide all of that by 0.0212. Okay, so now solving this, we will have our t. And remember, we're going to round it 1 decimal place. So the 6 is 1 decimal place, but y'all just got an 8 behind it. So we're going to round that 6 into a 7 and make that a 14.7. All right, so that makes sense. 6 years, the population was 6.7. So to get it up to 8 million, it took another couple years. It took it about so that was 6. So about what, 8 years, a little over 8 more years. Okay. It went from the 6.7 up to 8 million. So all right, y'all, part D on that one. So let me turn it over. So part D wants to know the double time is, so the doubling time is blank years. All right, so remember, it went from basically 5.86 to 8 million, and that was basically almost 15 years we figured out. Well, we want to know how long will it take this population to actually double. So from 5.86 up to 11 point something. But y'all, we got a formula. So we'll use the formula that has t, which is double time, equals the ln of 2 divided by rk. Now we already know what k is. K was 0.0212. So plugging into our formula, we'll have the ln of 2 divided by 0.0212. And y'all, once again, they are rounding me 1 decimal place. So let's go see what an ln of 2. So ln of 2, close parentheses, and then let's divide that by our 0.0212. All right, now we know it better be more than 14.7 because at 14.7 years, our population was just at 8 million. So here we go, y'all. Let's see how long it'll take the population of this city to double. And y'all rounding at one decimal place, I get what, 32 point, well, that 6 is in the first decimal spot, but it's got a 7. So we'll make that it's got a 9 there. So that 9 is going to round that 6 up to a 7. So I'm going to have 32.7. And then, like I said, MathLab will have the years already. So you just punch in the 32.7. So 32.7 years, that city's population will be over 11 million because it would have doubled by then, okay? So y'all, that's how we can use this population formula for a city. Your Game and Fish Commission might look at the population of deer so they can find a formula that bases their growth rate on what they've taken in as data. And they can sort of figure out formulas and predict the population of deer in a state and stuff like that. So that's sort of what you'll see with that one, okay? All right, y'all. So this next example, they're telling us complete the following table. All right, y'all. So for this table, they're giving me the population over here. Population, they'll have country A and then country B. Then we got our growth rate, which is our K. Now, country A, they already give me it. They're giving me 1.2% per year. But they're not giving me country B's growth rate. Now, the last column, they got our double time. Remember, that's our capital T. Now, they're not giving me the double time for country A, but they are giving me the double time for country B, and this one is 27 years. So it looks like they want us to find the growth rate of country B, and notice how they got the answers. We're putting them as a percent, okay? So MathLab will actually have this percent on that one, okay? And then this double time for country A looks like we're doing in years, okay? All righty. Well, we got formulas to find all of this stuff. So let's play with country A and figure out country A's double time. So this will be capital T and a little a. So remember, T is double time. And then when I put that little a there, that means I'm doing the double time for country A, okay? So that's what a lot of times why we use a subscript is to distinguish between two different cases of data, okay? So this is the double time for A. Well, we know that equals what? Ln of 2 over my K for A. Well, I know the K was 1.2%, but y'all remember, I can't put 1.2% into my formula. So the double time of A will equal to ln of 2. Now, if we turn 1.2% into a decimal, we're going to move it left twice, and that'll give us a 0.012. Okay, y'all, so remember, I'm just moving that decimal left twice. Now, it looks like they've got one decimal place. Whoops, which one I'm on? I'm on the years here first, right? Round them a double time. So that's in years. So it looks like we're going to round it to the nearest years if we need to. So they're not using no decimal places on their double times here. So we're going to punch in L in a 2 and divide that by 0.012. Y'all, here we go. L in a 2, close parentheses, divided by 0.012. And I'm getting 57.7. So I'm going to round my 57 up to 58. So I'm going to round this up to 58. So I'm a double time for country A, 58 years. So now what are we looking for? We're looking for the growth rate of country B. So we're looking for the K for country B, which will be the L in a 2 again, divided by the double time for country B. Well, it gave me that double time right here. So we're basically going to have K of B equals the ln of 2 divided by our 27 years. All right, y'all, so let's divide that out, and they're doing one decimal place on this. So let's see what that'll give us. So my ln of 2, close parentheses, divided by 27 years. All righty, so I'm gonna write a little bit of this down real quick so I can show y'all what we're doing. I got 0.02567. So I'm just going to write down a few of these digits and show you what we got to do. So this is decimal form. They want it in percent. So if you move left to go to percent, you're going to move right. You move left to go to decimal, you're going to move right to go to percent, okay? So you're going to move this decimal twice. So that's going to give us a 2.567. And this is now percent. But guess what? We need to round that one decimal place. So convert it out of decimal into percent, and then one decimal place will be where the 5 is. Well, y'all look at that. I got a 6 behind the 5. So the 5 will become a 6. So then I get 2.6%. Now remember, when you write your answer in, they've got the percent all right. All we're putting in is our 2.6. Okay? All right, y'all, that's all we had to do. Use those two formulas to find those two items. And they're doing this to show you that if you got growth rate, you can find double time. If you got double time, you can find the growth rate really quick by doing the ln of 2 divided by those, okay? All right, y'all, any questions on this yet? So this section is not real bad. This section is all about plugging stuff into those two formulas. All right, y'all, so now we're going to use this one for an investment. So we're going to suppose $14,957 is invested at 6.4% compounded continuously okay, so that's the difference between this one and the other day in 9.3 it was. Over there, we gave you stuff like compounded monthly, quarterly, semi-annually, and all this. This is continuously. So we're going to use the formula with the E in it. So here comes part A. Just like in question 1, they want us to find the exponential function that describes the amount in the account after T years. All righty. This is probably what the government does to you when they take their taxes and you owe them tax money. You're getting taxed at a rate of like 10%, but I think that's continuous compounding. That's why you don't want to get in debt with them, okay? All righty. So basically, I got to find a formula to use to tell me how much money is in this account after these years T. So we're going to find P of T again. So I need my PO, my original investment, my original population, so forth. So I'm looking at my original investment amount. Well, y'all, they gave that to us. They said that was 14,957. So it just starts out just like the other formulas we did earlier in the week. Okay. Your principal, your starting amount, your original investment. Now, the difference is instead of starting parentheses, we now have our E. And then we need KT. So what I need to know is, what is my K? What is my interest rate? They gave that to us. They said it was 6.4%. So if we move that decimal left twice, we're going to get a 0.064. So that's probably the most tedious thing on this formula is having to convert back and forth from percents to decimals and vice versa. So I would put in my 0.064, and then that gets multiplied times T. And y'all guess what? This right here is what Math Lab wants on part A. They want the basic formula. So now watch this. They say, what is the balance after T equals 1, 2, 5, and 10 years? So 1, 2, 3, 4 different years that I got to plug into that and see what the amount is. And they're rounding this to the nearest cents. That means 2 decimal places. Okay. So you got to round to the nearest cents. All righty, so I'm just going to put my times over here. So when t equaled 1, I had t equaled 2, t equaled 5, and then t equals 10. Now, you can go in one by one and put a 1 in here, figure out what you get, put a 2 into that, figure out what you're going to get, and so forth. But y'all remember, if I'm looking up more than one amount, I can graph this and use the table. So I'm going to go graph it. So y'all let me clear everything off. I'm going to go to y equals. I'm going to put in my formula. 14,957. And then I'm going to hit second ln to get the e with the exponent. And I'm going to put in my 0.064. Now remember, if I'm graphing it, I got to use x as the variable instead of t, okay? But it don't matter. It's going to give me the same amounts. So now I know what years I'm going to find. I'm going to go to second graph to go to my table. Now that makes sense. When x was 0, I had $14,957. Well, that made sense, right? So they want to know after 1 year. So there's one. But y'all look at that. It says 15,946. It's not rounded off in the nearest cents. It rounds it off to the nearest dollar. So let me show you a trick. If you arrow right and highlight the 15,946, if you go down below now, it says Y1 equals 15,945. I can now round that off 2 decimal places because it's giving me the whole decimal. So when t is 1, I'm going to make that 15,945.54. Now the 4 has a 4 after it, so I'm going to leave that as a 4, and that'll be 54 cents. Okay. So then they wanted me to do that for 2. So if I come over here and go down to 2 for my x's, the nearest dollar was the 16,999, but I want to click on it so that I can get the nearest cents. And that looks like 16,999.42. So the 2 has a 3 after it, so I'm going to leave that 42. So y'all, if you ever want to see the decimal approximations, you click on the actual Y value and it shows it in the little bar right here, okay? All right, so going left, I need to go down to 5 now. So there's 5, we're over 20,000 now. So let's round this one 2 decimal places. We got 20,597. Point, y'all look at that, 69. The 9 has a 9 after it. So the 9 is going to round to a 0. But y'all, if you round a 9 to a 0, that means the 6 becomes a 7. So that's going to round off 20,597.70. And then y'all look here, my last year, go down to 10. 6, 7, 8, 9, 10. It's over 28,000 now. So rounding that one, I got $28,365. And then that's what, 66. I'll keep that because of the 4 after it. So we'll keep that 66 cents. That's why I love my calculator and I love the graphing features because you can plug in your equations and then look at the x's for these values, okay? So y'all, I'm going to let y'all work this one for me and see what y'all get. And we'll do this one before break. So y'all, tell me this answer. The doubling time is blank years. All right, so y'all got plenty of formulas. Based on this problem, tell me what is my doubling time, okay? And you're rounding that off 1 decimal place. So round that answer off 1 decimal place. Just to see what y'all get on that, okay? But y'all will say it's going to be close to this right here, right? Look, there's 28,365. I'm starting with 14,009 something. It ain't quite doubled at this place, but it's getting close. So let's see what y'all get for that. Oh, Jackson's popping in with a 10.8. And I think you got it, Jackson. Good job. All right, because we had our T equaled ln of 2 over our K. We all ln of 2 stays the same on top. And we know our K, y'all done put K into my formula. That was 0.064. So y'all watch this, let's see, I'll punch it in. So get off my graphing. So I had an ln of 2 divided by 0.064. And we got 10.83, which we're going to round to a 10.8. Good job, Jackson. Perfect. So if you ever get continuous compounding and you know what your interest rate is, you can see how long it'll take you to double your money in that account, okay? Oh, all right, y'all. I'm showing it's about 10 till for us. So let me pause this. And we'll take our break, and we don't have much left. So take your break, and we'll come back at 11 o'clock and knock out the rest of 9.7, okay? And I will see y'all in 10 minutes. All right, everybody, I am showing 11 o'clock. So we will look at the last few problems here. And y'all probably do at least two of these, okay? These last three problems are all the same, and they're just using a formula. They're going to give us the amount of time, and we're just going to plug that into the formula and see what we get after that, okay? So for this next example, the number of books in a small library increases according to the formula So they're giving us our formula. It says B equals, so B must be the number of books. So the books is equal to 3,700 E to the 0.02 T. So it's increasing exponentially. My growth rate is the 0.02, and then T is the number of years. And then it says where T is measured in years. So what they want to know, how many books would a library have after 2 years? All right, so they're giving me the formula B. So basically, this is the number of books. So basically, if I was going to write it in function notation, I'm looking for the number of books after 2 years, since 2 is my T on this, okay? So that's going to equal 3,700 E to the 0.02 times my T, which is 2 years. Now, if it's increasing like they said here, you got to get more than 3,700 because 3,700 was their starting amount, okay? So y'all, all I would do is just go punch this on the calculator, and they're rounding it to the nearest book. Oh, y'all, my bad. I ain't even got us going. Okay, so let me start that over then. How about that? Because y'all, I didn't even have my camera recording, I don't think. All righty, so let me get us resuming, and then let me share my screen. All righty, so y'all, here we go. So the number of books in a small library increases according to the function B equals 3,700 E to the 0.02 T, and then it says where T is measured in years. Okay, that should have had two C's there. Okay. All right. Then they say, how many books would a library have after 2 years? All righty. So they gave me the formula. B equals 3,700 E to the 0.02 T, where T was measured in years. Well, they're giving me how many years? 2. So we're finding basically B of 2. If we was writing it like a function notation, okay? Now, that's going to equal to 3,700 E to the 0.02 times my T, which is the 2 years. Okay. All right, y'all. So let's share the calculator and we're going to round this out to the nearest year. So no decimal places. And then this one's usually multiple choice for you. So they'll give you 4 answers. All righty. So here we go. 3,700. Second LN to get my E. And then I had 0.02 times 2. All right, y'all. So when I hit enter, we will get 3,850.99. I'm going to round that up to 3,851. So always round up to the nearest book on that. And then y'all, I'll show you, they got the answer blanks on that one. So we went with A, 3,851. Okay. All right, y'all. So 5 is the same thing, but instead of books, it's the population of a small country. Increases according to the function B equals 2,400,000 E to the 0.03 T. And then it says where T is measured in years again. Well, what they want to know is how many people will the country have after 3 years? So they're still using B on this one, which I'd probably use the P since I'm dealing with population. But they're giving us the formula again. So we're looking at 3 years for our T this time. So we're basically finding B of 3. So it's going to equal 2,400,000 times our E to the 0.03 times T, which they gave us of 3 years. All righty, we're rounding it off to the nearest millionths on the population. So once again, no decimal places. And it's increasing, so it's got to be more than 2,400,000, okay? So let's go share that on the calculator. And 2,400,000. Second ln 0.03 times my years, which was 3. So y'all, we got a formula in. Let's hit enter. And we're getting 2,626,018.2. So since that's a 0.2, I'm going to leave that as an 18. So I get 2,626,018. Okay, so they're rounding that off to the nearest millions. All right, y'all. So these two notice deal with increases. So our last problem is going to be one where it's a decrease. So the number of acres in a landfill is given by the function B equals 3,800 e to the negative 0.05 t. So when I see a negative up here, that means it's going to be a decrease or a decay type situation, okay? When this is positive, it increases. When it's negative, it's decreasing. So what they want to know, how many acres would a landfill have after 9 years? And they want me to round it to the nearest acre. So I'm starting out with 3,800 acres. It's a negative growth rate, which means it's going to be a decrease or a decay. We know the years was 9. So y'all, we're going to plug it in. We're looking at B of 9, which equals 3,800 e to the negative 0.05 times 9. All right, y'all, so punch that in and tell me what we get for how many acres there are after 9 years. And remember, y'all rounding it to the nearest acre, so no decimal points, okay? All right, well, Jackson, you're pretty good on that thing, so it is definitely 2,423. So we'd punch that in, and then MathLab will have the acres part, okay? All righty, y'all. So these 3 problems are just examples using that formula to find different things. How many books are in the library? Population of a small country. Acres in a landfill. The other examples we did, what was that? That was population and investments. So a lot of uses with this formula depending on your situation, and as long as it is continuous compounding, okay? All right, y'all. So any questions on that? All right, so let me stop my share. Well, I need to give y'all a few things now. So let me give y'all a few things this week. So Tuesday tomorrow, we're going to review test 4. Wednesday, we're going to review for the final exam. Now, Wednesday, the final exam will open on Wednesday, okay? So we're going to review for the final exam. Thursday, I'll go over any questions because before I did the final, I would do the review. And if there's anything bothering you on the review, Thursday we will fix up anything bugging you, okay? So that'll sort of be a day where we just go over anything that y'all need. But y'all, here's the thing. On Thursday, which is 3 days from now, the final exam is due by midnight. Hey, we won't have class Friday because class is going to end Thursday night at midnight. So if you don't have anything done in math lab, it's going to zero y'all out for those assignments. Everything has to be done by midnight on Thursday, okay? So we're reviewing for test 1, test 4 tomorrow. I would knock out that test as fast as you can. That way you can focus on this final exam, okay? Now, the final exam is 25 multiple choice questions, and we will go over all 25 of those on Wednesday morning, okay? And y'all, I've been having issues with Math Lab trying to create links for your homework, so I'm not even going to ask for homework problems on test 4 because I can't get my links to working. I think the portal's having issues since we're migrating into the new Blackboard for the fall. So the old Blackboard is getting a little wacky now. So yeah, so tomorrow that's all we're doing, review test 4. And then Wednesday, all we're doing, we're reviewing for the final. Now, any questions? Hey, also day, not really a bad day today. We have finished all the new material you're going to learn for the year. So now it's just knocking out these last 2 tests, okay? So y'all, what you do, if you're going through your um review test today would be a good thing to do for test 4 also after you knock out your homework. See what you can get done on review test 4. That way tomorrow when we review, we can fix anything y'all had any questions on, okay? Well, Macy, I was going to, but since I'm having issues with the math lab, I'm not even going to penalize y'all for work on that one. And then most of y'all in this class, I know are coming and going to our lectures, so I'm not as worried about y'all. So um, just knock it out and do the best you can on it, okay? All righty, y'all. Any more questions for y'all? All right, so like always, if you got any issues, email me, okay? So pretty light day today. Y'all knock out that 9-7, and then if there's any other homework you need to catch up, try to get that all done. That way we can start focusing on these last 2 tests, okay? So y'all, I'm going to stop my share and give me about an hour and I'll have this video to you.